Welcome to the lecture. In this lecture, we are going to discuss about the 8086 microprocessor. 8086 architecture is different from 8085, whereas 8086 microprocessor is an enhanced version of 8085 microprocessor that was designed by Intel in 1976. It is a 16-bit microprocessor having 20 address lines and 16 data lines that provides up to 1 mega bytes storage. It consists of a powerful instruction set which provides operations like multiplication and division easily. It supports two modes of operation, that is maximum mode and minimum mode. Maximum mode is suitable for systems having multiple processors, and minimum mode is suitable for the system having the single processors. So before getting into the architecture of 8086, we should discuss about the features of 8086. The most prominent features of 8086 microprocessor are as follows. It has an instruction queue which is capable of storing 6 instruction bytes from the memory, resulting in faster processing. It was the first 16-bit microprocessor having 16-bit ALU, 16-bit registers, internal data bus and 16-bit external data bus, resulting faster processing. It is available in three versions based on the frequency of operations, that is 8086 for 5 MHz and 8086 for 8 MHz and C80861 for 10 MHz. And third one, it uses two stages of pipelining. It is the most important features of 8086. It uses two stages of pipelining, that is fetch stage and execute stage, which improves the performance. So fetch stage can prefetch up to 6 bytes of instructions and stores them in a queue. Execution state executes these instructions. It has 256 vector interrupts and it consists of 29,000 transistors. And now we can discuss about the architecture. So here you can see that we have a memory interface, and the architecture is basically divided into two, that is BIU and execution unit, bus interfacing unit and execution unit. In execution unit you can find the arithmetic logic unit, as it performs the ALU operations, arithmetic and logical operations. And here you can see that is A, B, C, D. You have 4 registers high and 4 registers low, that is AL and AH and AL, and we have the other SP, BP, SI and DI registers, which is used for storing and stack pointer purposes, and we have also the control bus in the execution unit. And in the above section you can see we have a memory interfacing, which is used to interface with the external devices, and in the bus interfacing unit we have there are two buses, that is B bus, which is comprises of the registers and IPs, and in the C bus you can see it is connected to the instruction streamline. Here the 1 2 3 4 from 1 to 6 we have 4 registers where we can keep that pipelining technique to store the instructions up to 6 bytes. And to get a deep understanding, first we can discuss about the bus interface unit. It provides the interface of 8086 to external memory and input-output data via the system bus. It performs various machine cycles such as memory read, input-output read, etc. to transfer the data between the memory and the input-output devices. So BIU, that is bus interface unit, performs the following functions such as it generates 20-bit physical address for memory access. It fetches instructions from the memory. It transfers data to and from the memory and the input output. Maintains the 6-byte prefetch instruction queue that supports the pipelining. So we have mainly 4 segments and the instruction point and the prefetch queue and address generation circuit. So these are the 4 main features of BIU. And instruction pointer, here it is a 16-bit register. It holds the offset of the next registers in the code segment, and IP is incremented after each instruction byte is fetched. So once the instruction from the pipelining is fetched, the instruction pointer will be getting incremented, and IP gets a new value whenever the branch instruction also occurs. And next is code segment register, that is CS. Code segment, data segment, stack segment, extra segment, which we can found it as ES, CS, BS, etc. These registers have the base address. This holds the base address for the code segment, holds the base address for the data segment, for the stack segment, and for the extra segment. And these four are 16-bit registers. And coming to the address generation circuit, it is a physical address generation circuit. It generates 20 physical address using segment and offset address using the formula. And coming to the 6-byte prefetch queue, you can find from 1 to 6. We have 6-byte queue, FIFO concept. There is first in and first out. Fetching the next instruction while the executing the current instructions called as pipelining, gets flushed whenever the branch instruction occurs. And prefetch unit, you can find it in the 8086. It is a component responsible for fetching instructions from the memory and storing them in the queue. And the execution unit, here you can find special registers, general purpose registers, ALU, instruction register, instruction decoder, flag and status registers. So main functions are fetches instructions from the queue in the BIU, decodes and executes arithmetic and logic operations using the ALU, sends the control signals for the internal data transfer operations within the microprocessor, sends request signals to the BIU to access the external module. It operates with respect to T states, that is T which we have discussed in the machine cycles, and not T state cycles and not the machine cycles. In the next, we can discuss about the interrupts which we find in 8086 and the difference between the interrupts of 8085 and 86. Thank you.